Okay, part two. Everybody got part two? Write that down. Okay? P1 is called the combined gas law. P1 V1 over T1 is equal to P2 V2 over T2. P1 V1, write that down, the combined gas law. Initial, final. Okay, so pressure, we talk about pressure in terms of atmospheres in chemistry. Okay, so that's our unit of, so atmospheres, right? We said 1 atmosphere is 15 pounds per square inch, and that's kind of our standard here. So when we are standing here, we are feeling about 1 atmosphere of pressure from the atmosphere. Okay, we talk about volume in terms of liters, okay, and temperatures in Kelvin. And yesterday we talked about how to get Kelvin. What do you do to get to Kelvin temperature? All you do is add what? 273, right? So that formula that's on the front side to get to Kelvin, all you do is add 273. So we're going to use this gas, okay, when we're undergoing a change, all right? So when we're undergoing a change, we are going to use this gas, okay? So if I want to figure out, like, the stipulations behind a balloon of sorts, when let's say it's like this one of these hot summer day problems, or cold summer day, or cold winter day, okay? If I want to know something about what's going to change to the balloon, okay? If I got this balloon right here, right? Everybody would agree with me that the temperature in this room, right? Right? And the pressure in this room, the atmospheric pressure in this room, whatever it is, right? And then the volume of this balloon is just public. Okay? So if I walked outside right now, well, it says at 4 o'clock it's going to be different. The temperature is going to change. Okay? So the molecules inside this balloon are going to behave differently. And we want to figure out how they, when they behave differently, what's going to happen to the balloon. Okay? So when a gas is changing, you have initial conditions, which would be this room, and the final conditions would be like going outside. So like for instance, yesterday, when before Felix jumped out of that capsule that we watched jump out of, the initial conditions were here on Earth. The final conditions were up in outer space. So they had to think about what are going to be the initial and what are going to be the final. How is the balloon going to behave as they send them up? Okay, so let's do a problem. All right. Now there's a couple tricks I'll show you here. So let's talk about this. The hardest part is associating values with your initial variables. Okay. So if I have a gas, if a gas has a pressure of 3 atmospheres and a volume of 0.56 liters, what will the pressure be if the volumes increase to 2.9? Okay, so let's just write our equation. P1 is initial pressure, P1 is initial volume, T1 is initial temperature. Okay, is equal to P2, final pressure, final volume, temperature final. Okay, now here's the trick. Make sure you're watching and not on your phone. Okay? When it says constant, okay? So constant temperature, we can cross that variable out. What variable is temperature? T, right? So if you are given constant, cross it out. We don't even care about it. That means it's not changing. So we don't even want to account for it. Okay? So now my equation becomes P1 V1 is equal to P2 V2. So in the problem, whatever it tells you is constant, you just cancel it out. Okay? So now let's plug in our stuff and solve. All right? The volume or the pressure is P1. Remember, atmospheres is pressure. Volume is liters, V1. Okay, see how I'm just going through and I'm reading the question. I'm kind of assigning the variables. In the volume, what will the pressure be, P2, when the volume's increased to 2.9, V2? Okay? Does everybody see how I went through and I assigned those variables, right? There's no temperature, so we don't even worry about it. Now let's plug it in. P1 is 3.0 times V1, which is 0.56, is equal to P2, that's what we want to solve, times 2.9. How am I going to solve this equation? Just divide, right? Because we're multiplying, okay? So if I want to solve for x here, that's x, what do I do? It's this times this, so I'm just going to divide over, right? And most of it is going to be cross multiplying and dividing, okay? Or just solving for a variable. So it's simple, it's just algebra, right? So I'm going to divide by 2.9 to each side, okay? And then my answer will be 0.57 atmospheres. So that would be the pressure of the new balloon, okay? So now we have a quantifiable number behind it. All right? Let's do another one. Ready? So every time you start with P1 V1 over T1 is equal to P2 V2 over T2. So the question says this: a balloon occupies 3.7 liters at 25 degrees Celsius. Okay, what will the balloon be at? What will the volume of the balloon be at when it's 87 degrees Celsius? So I have constant temperature, pressure. So what do I do with constant pressure then? What do I do when it tells me that variable is constant? Just take it away, right? So just cross it out. Okay, we don't need pressure then. So then my new equation is going to be V1 over T1 is equal to V2 over T2. Okay? Now let's plug in what we want to find, so a balloon occupies V1, which is 3.7 liters, right? At T1, good so far? Okay. What will the volume be, V2, when the balloon is at T2? Okay. So V1 is 3.7, okay, over 20. Can I just plug 25 in, or what do we have to do to that 25? Anybody remember? Not times, but what do we have to, what's the temperature that we like to be in? And not Celsius, what do we like to be in? Kelvin. How do I get out of Kelvin? Remember this formula right here? All the way back. What do I do to get into Kelvin? I add, Kelvin's equal to 270, just add 273. Okay? So I'm going to go back to my problem. And I just like to do it like this. I like to put it all in at once, like 25 plus 273. You can do it before. Okay? Remember, you have to get into Kelvin temperature. Is equal to V2 over 87 Celsius. I can't be Celsius. I have to be Kelvin, so I add 273. Right? Now, how am I going to solve for x? Just multiply across, right? So you're just going to multiply. Everybody just multiply over, right? Sound good? You just go 3.7